Okay, today we're going to be talking about Go Math 6.7, subtracting fractions with mixed numbers and regrouping. This seems like a really tough one. It actually is probably as hard as it gets in 5th grade with fractions. It's a combination of everything we've learned, but hopefully this will make a lot of sense. I simplified it into 2 simple problems. I'm going to work this first problem out as I explain the rules, and then I'll help you with a few other problems. So the first part, rule number 1. See if your denominators are the same. Okay, your denominator are the numbers on the bottom. Okay? See if they're the same. 3 and 12 are not the same. If they're not the same, there's a second part to rule number 1, which is if they're not the same, you need to make them the same. So how do you make them the same? First of all, you need to find a number that they can both fit into. Now, 3 can fit into 12, but 12 can't fit into 3. You need a number they can both fit into, so why not go with the bigger number and make them both 12? This makes it easy, because this one's already 12, you don't have to change it at all. You do need to change the 3 though, so to make a 3 into a 12, you have to multiply it by a number. 3 times 4 equals 12. Whatever you do to the bottom of a fraction, you have to do to the top. So if I multiply 3 by 4, I have to multiply 2 by 4. 2 times 4 is 8. That gives me 8 twelfths. So now, instead of 2/3, I have 8 twelfths. So what I'm going to do is I'm going to get rid of this. I'm scooting it up here so we don't look at it anymore. Go over 8 twelfths. Okay. And I have 3 and 8 twelfths minus 1 and 11 twelfths. Okay. So rule number 1, now our denominators are the same. If not, make them the same. We did, and we're ready to move on. Rule number 2. Subtract or add straight across. Okay? The first thing you're going to want to add or subtract are your fractions. Okay? 8 minus 11. Here's where we run into the second if. You can't take 11 away from 8. So we have to do something else. If there's a smaller number on top, borrow. Okay? There's a smaller number first, so we need to borrow. Now borrowing with fractions actually is not too tough. Okay? And to do this, I want to show you using egg cartons. Okay? I'm going to create a fraction to show you exactly how many we have. 3 and 8 twelfths. Okay? To have 3 and 8 twelfths, the 3 represents 3 whole groups of 12. That is like eggs. If you have 3 dozen eggs, it looks like that. The 3 represents 3 cartons full of 12. Okay? The last one's a fraction, which means I have 8 twelfths. Okay? Here's my 8 twelfths. To show you 8 twelfths, that would mean out of the 12, I only have 8. So I'm going to cross out 2 rows, 12, 10, 8. That means I have 8 left. So in here, I have 8 out of 12, and I have 3 whole sets. That's 3 and 8 twelfths. Okay, I'm going to do the same thing over here. 1 whole set, so that's 1 set of 12. That's the whole number. And then 11 twelfths. Okay, for my 11 twelfths, or for the fraction, I'm going to have to cross one of those eggs off. I know it's tiny, I'm sorry. But inside there, there's 11. Okay? So here's how you borrow. To borrow, I'm actually going to take one of the whole sets, and I'm going to add it to the 8 I already have. Okay? I can't do it with that one, so I'm going to do it with this one. Okay? What that leaves me with, instead of 3, it leaves me with 2 whole sets, and then 8 plus the 12 I just added to it. So 8 plus 12 is 20. Okay, so on top I'm going to have 20, but I took those from here, from the 3, and now I only have 2. So I have 2 and 20 twelfths. This makes it so this number's bigger, and I can subtract the 11. Okay? So then I take 20 and minus 11. Okay, so I'm going to take out of this 20, get rid of 11. 20 minus 11 is 9. Okay? It's still out of 12, so the 12 doesn't change. But what I just did was I took 20 out of there. So I'm going to get rid of those. And I took rid of 11, got rid of 11, now I have 9. I still have my 2 whole cartons, and I'm going to get rid of 1. So I have 2 minus 1 is 1. Okay. If I got rid of 1, bam, 1's gone. I still have my 2. Okay? That gives me my end fraction, which is 1 and 9/12. Here's the tough part. This is where you have to simplify. Okay? 9/12 is not as small as it can go. You have to find a number that can go into both of those. That's a common multiple. Okay, the common multiple for 9 and 12 is 3. 3 goes into 9 3 times. 3 goes into 12 4 times. That gives me 1 3/4, and that's my final answer. These are pretty long problems that are a little difficult for 5th grade, but if they take it one step at a time, they can do it. Okay, here's number 6 on their page. And what I'm actually going to do from here on out, just because it's a little easier for me, is I'm doing the same problems, but I like to move them so they're parallel. It's a little easier to work on, and maybe you'll see why. Okay, so you'll notice on number 6 that it's actually the same problem. I just put it on top of each other. Rule number 1, see if your denominators are the same. 4 and 3. They're not the same. And in this case, 3 doesn't go into 4 and 4 doesn't go into 3. So we need to find a number they can both go into. I usually will count with the top number by 4s until I find a number that a 3 can go into. 4, 8. Okay, 3 doesn't go into 8. 12. Good. 3 goes into 12. So we're going to choose 12 as our common denominator we want to turn both of them into. So I draw it out here. I want to make both of them 12. 4 times 3 is 12, and 3 times 4 is 12. Now I need to remember that what I do to the bottom, I do to the top. So 1 times 3 is 3. 3 times 4, I have to do the same to the top. 1 times 4 is 4. Now what I just did is I got rid of all these, and I have a new denominator. The whole numbers stay the same, so 4 and 2 stay the same. Now it's time to subtract. Subtract or add straight across. Okay, in this case, up and down. Can't take away 4 from 3, so we need to borrow. To borrow on this, we need to take it from the 4. So to get it from the 4, that 4, remember, represents 12. Okay, because it's actually a whole group of 12. So that 4 is now going to become a 3. I'm going to do it out here because I've lost room. Then I need to add the 12 to the 3 I already had, which makes 12, 13, 14, 15. So I actually have 15 twelfths minus 4 twelfths. Instead of a 4, now I have a 3 because I borrowed from there, and I still have my 2 over here. Now I just can go straight across. 15 minus 4 is 11, and 3 minus 2 is 1. And 11 twelfths is already in lowest terms, so that's my answer for number 6. Alright, we're only doing the evens. Here's number 8. Step number 1, see if my denominator is the same, 9 and 6. They're not the same, so I need to make them the same. To make them the same, I need to find a number they can both go into. In this case, it's going to be a very big number, 50, sorry, not 56, 54. So they're both going to become 54. This one's easy. 9 times 6 is 54, and 6 times 9 is 54. So now I have to do the same thing to the top. 5 times 6 is 30. And on the bottom, 5 times 9 is 45. Okay. My 7 and 2 are going to stay the same. Okay. Just so I don't get confused, I'm going to erase all the stuff over here, and also to give me a little more room. Then I need to subtract 45 from 30. Okay, subtract or add straight across or straight down. If smaller, the number on top, 30, I need to borrow. So to do that, I'm going to have to add 54 to 30 and take it away from that 7, which makes it 6. Okay. But now I need to add 54 to 30. That gives me 84 over 54 minus 45 over 54. And I have 6 and 2. Okay. Now I need to subtract 84 from 54. If I need to do that, I can do it up here. 84 minus 54 gives me 0 and 3. 30. 30 over 54. And then the whole numbers are easy. 6 minus 2 is 4. Now, is that in lowest terms? The answer is no. They're both even, so I know at least 2 will go into them. 2 goes into 30 15 times. 2 goes into 54 27 times. And that's as low as it can go. Sorry, I'm a liar. It goes smaller. 3 goes into 15 5 times, and 3 goes into 27 7 times, 3 9 times, 4 and 5 9s. Sorry, even teachers are wrong sometimes. So. Alright, double time just so we can get this done. This is number 10. See if your denominators are the same. No, they're not. So I need to make them the same. Since 5 fits into 10, I'm going to make 10 the denominator. 5 times 2 is 10, so 1 times 2 is 2. My top becomes 2, my bottom becomes 10. So I have 2 tenths. Okay? The top's too small, so I have to borrow. Borrow from right here. That makes that a 1. And I add 10 to the top, which is 12. 12 minus 9 is 3. My denominator stays the same. And 1 minus 1 is 0. You don't need to write the 0. So your answer for number 10 is 3 tenths. Number 12 is a little more tricky. You have 6 minus 3.5. Now, I know it looks hard, but all you have to remember is that this one of these holes is the same as 2 seconds. So I'm going to start out just by borrowing, and I'm going to make that 5, and I'm going to take the 1 and make it 2 seconds. Okay? That way, my denominators are already the same, and I can start subtracting. 2 minus 1 is 1, still over 2, and then 5 minus 3 is 2, 2.5. That one's nice and easy. Number 14. My denominators, first I check, are they the same? No. I have to find a number they can both go into. Okay, I could do 6 times 8, which is 48, but if I did 24, it actually is a smaller number, and it makes figuring out the simplest form at the end a little easier. 6 times 3 is 24, so 1 times 3 is 3. 8 times 3 is 24, so 5 times 3 is 15. Okay, so I just got rid of that part and changed it. Next, my bigger number, or the top number, is small, so I have to make it so it's bigger than the 15, so I can subtract. I'm going to borrow from the 9. I'll make that 9 8. But then I need to add 24 to the 3. So 24 plus 3 is 27. Now I have 27 24ths minus 15 24ths. So to subtract that, I'll have 12 24ths, and 8 minus 3 is 5. Now, I'll notice that the top, the 12, is half of 24. So to simplify, I could just say 12 divided by 12 is 1. 24 divided by 12 is 2. So my answer is 5.5. Here's number 16. 6 and 5, are my denominators the same? No, I need to make them the same. 30 is the smallest number they will both go into. To make 6 into 30, I multiply it by 5. 1 times 5 is 5. To make 5 into 30, I multiply it by 6. 4 times 6 is 24. I've changed both my fractions. Next step, 5 is too small to take 24 away from it, so I need to change 13. I'm going to borrow. That 13 is now going to become 12. And I have to add 30 to the 5, which makes it 35. 35 minus 24 is 11 over 30. Now I subtract my 12 minus my 3. 12 minus 3 is 9. And that is the answer. Alright, this is the last one for this assignment. 8 and 9, are they the same? No, they're not. We need to find a common denominator. In this case, the easiest thing would be to multiply 8 times 9, which is 72. 72, they both can fit into. Okay? To do that, I have to multiply 8 by 9, which means I have to do the same thing to the top. 3 times 9 is 27. 9 times 8 is 72, so 7 times 8 is 56. Okay? I just took care of that. I know it's tough, but it makes the denominators the same, and that's what we need to do. Now I can't subtract 27 from 56, so I need to borrow. So I'm going to borrow from my 7. That 7 now is going to be a 6. And I have to add 72 to 27. 72, I'm going to use this real quick to add. This is 9 and 9, so 99. So now I have 99 70-seconds. Wow, that's huge. Okay, now I actually have to subtract. 99 minus 56. 9 minus that is 3. 9 minus 5 is 4. So I have 43 over 72. Then all I have to do is subtract my whole numbers. This is the easy part. 6 minus 2 is 4. My answer is 43 70-seconds. I know this is tough, especially for 5th grade. That's part of the reason I've been putting the answers on there, and I hope it helps. Thank you.